Okay, picture this for a second. You look up at the sky, and instead of that clear blue expanse we're all used to, there's a shadow, a massive looming shadow. An asteroid is hurtling through the vacuum of space at tens of thousands of miles per hour, and it's on a direct collision course with Earth. Alarms at observatories all over the globe are just blaring. The countdown has officially begun. Welcome to Curious Orbit. In today's explainer, we're diving into the absolute highest stakes scenario imaginable. What if an asteroid hit our planet tomorrow?
It's the ultimate chilling hypothetical, right? It's fueled science fiction blockbusters for decades. But if we strip away the Hollywood dramatization and just look at the cold, hard, uncompromising science of planetary impacts, the reality is actually way more terrifying. If a mountain-sized rock suddenly appeared on our radar, zeroing in on a major city, we really have to ask the big question: would we actually survive?
Seriously, if a red alert suddenly flashed across the monitors at space agencies right now, what's our immediate next move? The window for action would be vanishingly small. Could our scientists actually stop it in time? We have to wonder if our modern space agencies and the technology we have right this very second are truly enough to intercept a celestial body carrying literally millions of megatons of kinetic energy.
Or would this mark the abrupt end of civilization as we know it? I mean, we're talking about absolute peak stakes here. The cosmos is unimaginably vast, and our pale blue dot is a really, really small target. But the universe operates on deep time, and as the fossil record clearly tells us, direct hits absolutely do happen. To understand the true magnitude of this modern threat, we kind of have to look back at our planet's incredibly violent past.
Earth has a long, really violent history with cosmic debris. I mean, we all know the story. 66 million years ago, an asteroid roughly 6 miles wide plunged into the Yucatan Peninsula, forever changing the trajectory of life and wiping out the dinosaurs in a massive planetary firestorm. These impacts have undeniably shaped Earth over millions of years. But here's the thing: humanity isn't just sitting around waiting for history to repeat itself. By 2022, we officially started fighting back, which is a monumental milestone we'll get into in just a minute. But the crucial question bridging that prehistoric past to our present reality is, what exactly happens if a large asteroid strikes today?
Well, to answer that, we first need to understand how we're currently monitoring the vastness of space, because scientists aren't just sitting back staring at the clouds waiting for the sky to fall. Right now, there's this incredible global network of observatories using advanced infrared telescopes to actively scan the cold, dark depths of our solar system. They're hunting for faint thermal signatures, basically the glowing heat of potentially dangerous rocks that happen to cross Earth's orbital path. And they find a lot of them. Every single year, NASA tracks thousands of near-Earth objects. Thousands! Now, the reassuring reality here is that the vast majority of these rocks pose absolutely zero threat to us. Their trajectories are precisely calculated, and they safely pass by in the dark millions of miles away. But what if a single, massive, undiscovered asteroid slips through that intricate detection net? Like a so-called city killer that emerges straight from the glare of the sun, where our telescopes are effectively blind. That is the absolute nightmare scenario.
So, let's run the simulation. Imagine one of those large, undetected asteroids suddenly breaches our upper atmosphere. To truly grasp the level of devastation here, we need to understand the brutal physics of a hypervelocity impact. This isn't just a heavy rock hitting the dirt. No, it's a terrifying continuous chain reaction of kinetic energy transfer that unfolds in the absolute blink of an eye, completely reshaping the landscape.
Here's how it plays out step by step. First, the asteroid enters Earth's atmosphere at an unbelievable velocity. We're talking exceeding 40,000 miles per hour. It's moving so fast that it violently compresses the air directly in front of it, generating unimaginable friction and heat. Then, the moment it strikes the surface, millions of tons of kinetic energy are released instantly. And this isn't just localized damage. A large asteroid would vaporize solid bedrock on contact, literally obliterating entire regions instantly. And almost simultaneously, shockwaves radiate outward through the Earth and the air with a force so massive that reinforced concrete infrastructure would just collapse, miles and miles away from ground zero.
But here is the truly terrifying part. The nightmare doesn't just stop at the edge of the crater. That initial explosion, that's simply the opening act of the catastrophe. The intense thermal radiation generated by the impact creates a flash of heat hotter than the surface of the sun, and that would instantaneously ignite massive firestorms. In Sierra forests, entire cities could be engulfed in a sweeping wall of flames, sending towering, apocalyptic plumes of smoke high into our upper atmosphere.
And that relentless rising smoke triggers a severe climate phenomenon known as an impact winter. This is where millions of tons of vaporized rock, soot, and debris effectively choke the stratosphere, wrapping the entire globe in this dark shroud that blocks out sunlight for months, maybe even years. Plunged into sudden darkness, global temperatures would plummet rapidly, completely crippling global agriculture. It's a cold, really sobering reality of how a sudden kinetic strike transforms into a lingering, planet-wide fight for survival long after the ground actually stops shaking.
Okay, take a breath. Apocalyptic doom is a terrifying thought, for sure, but it is not our inevitable destiny. We are not the oblivious dinosaurs just staring up at a falling star. Today, humanity is entering an unprecedented era of planetary defense. We have officially transitioned from merely observing the cosmos to actively figuring out how to survive it. And crucially, we are no longer defenseless against the void. Remember that question we asked earlier? Could we stop it? Well, the answer is shifting from a hopeful maybe to a definitive yes. Space agencies around the globe aren't just mapping the skies. They are actively engineering these brilliant, highly practical methods to physically deflect dangerous near-Earth objects away from our home. We are learning how to permanently alter their deadly trajectories. Which brings us to a truly monumental leap forward for our species in 2022. NASA's historic DART mission proved what was once thought totally impossible. By deliberately crashing a spacecraft into an asteroid named Dimorphos at over 14,000 miles per hour, humanity successfully executed a kinetic impact deflection. We actually changed the orbit of a celestial body in deep space. It's wild when you think about it. This serves as the ultimate proof of concept, and it gives us incredible science-backed hope for the future.
So while the threat of a kinetic impact absolutely brings terrifying realities, like the shockwaves, the firestorms, and the rapid global cooling we talked about, modern science has entirely flipped the script. Thanks to successful kinetic deflection tests, like the DART mission, and the tireless, round-the-clock planetary monitoring by our global space agencies, we are better equipped to protect our world than any species in Earth's history. The universe is undoubtedly dangerous, but our rigorous understanding of it has truly become our ultimate impenetrable shield.
So, the profound question remains. If those astronomical alarms actually went off tomorrow, and a giant asteroid was confirmed to be heading straight for us, do you think humanity could set aside its differences to step up and actually stop it in time? I really want to know what you think. Let us know your theories and your survival strategies down in the comments below. It's a fascinating, incredibly high-stakes debate. And hey, if you want to keep exploring the incredible, awe-inspiring realities of our universe, make sure to hit that subscribe button for Curious Orbit. We've got so many more science facts and cosmic mysteries to unpack together in our future explainers. So until then, stay curious and keep looking up, because you never know what might be looking back down.